So let's go ahead and graph this function. First, we'll go ahead and graph the original sine curve. And the original sine curve, as we know, starts at 0 and travels up to 1, back to 0, -1 and 0. And then goes the other direction. So there's my original sine curve. And remember that the axis here is y equals 0. And since the vertical shift is up 2 units, we're going to want to move every point up 2 units. So instead of my axis being at y equals 0, it's going to be at y equals 2. And then each point gets moved up 2 units. To look like that. Right, so every point got moved up 2 units, and the new axis is at y equals 2. Notice it's 1 above and 1 below, just like it should be. This is really important for when we have to start writing equations based on graphs. That's why I need you to get in the habit of drawing the axis as well as being able to find the axis given a graph. All right, let's go on to letter B. And our equation would be y equals sine of x plus pi over 3. And then there would be nothing on the y. All right, so I'm going to extend this out. And we're not going to have a vertical shift. We do have a phase shift, which is going to be left pi over 3. And there is no vertical shift. Now, when I have a phase shift that's something like pi over 3 or pi over 6, or not just a nice pi over 2 like what we're used to seeing here, I'll show you how we're going to do this. What we're going to do is we're going to draw our graph the same way, where we're going to let this be pi. This would be pi over 2. This would be 3 pi over 2. And 2 pi. Then I'm going to do the same thing here. Let's see, this looks extended that. Well, I guess this would be my pi over 2. This would be my pi, except these are negative. Now, since it's pi over 3, what I'm going to do is I'm going to take each of these sections and divide them into thirds. Okay. So this is a third of a half, which is technically a sixth. Okay. But that's okay. We know that 2/6 is the same as 1/3, but that allows us to be able to move a third of a unit. Right. So let's first just draw my initial one. Let's not get too concerned yet with moving it. Let's just draw our initial sine curve. Starts at 0, goes up to 1, back to 0, down to -1, and back to 0. Okay. So there's my initial sine curve. Now I'm going to move each point left pi over 3. Now again, since this is 1/3 of a half, see it's a third of this pi over 2, so 1/3 times 1/2 is 1/6. So this is 1/6, 2/6. 2/6 is a third. So I'm going to move 2 marks to the left. I'm going to move 2, I'm going to call them hash marks, left, because that would be 2 hash marks left would be a third of a pi. So I can move this one, 1, 2 would be right here. This one moves to there. So this is my new point right there. And then this one is going to move 2. This one moves 2. 2. There we go. And there is my new sine curve. Which brings us to our theorem. And our theorem says that for all, you should see this, real numbers x, that the cosine of x minus pi over 2, I want you to come up here to the very first phase shift one that we did. The one, example 2, letter B. Here's my new curve. If I had continued this, do you see this would have come down? That when I shifted my cosine curve to the right, pi over 2, I ended up with the sine curve. So if you shift the cosine curve pi over 2, you get the sine curve. Right, so we're going to look at equations and write phase shifts and vertical shifts. Anytime I do that, I first write this the translation rule. So my translation rule here is x minus pi over 4 and y minus 1. Notice that x lies, y tells the truth. So my phase shift, I look at the rule, is left pi over 4. My vertical shift is down 1. Then I go to part B. My translation rule would be x minus pi over 2, y plus 4. So my phase shift is left pi over 2 and up 4. Now, as you can tell, when we look at example 5, now that we're translating these and we're moving them left and right, up and down, you can't tell if it's sine or cosine. Which one is it supposed to be? So, since we can't tell, what we do instead is we have to write the equation for both. Now, there are some real easy steps that if you use these steps, you'll be able to find these equations easily. The very first step, and it's sometimes the step people try to skip, you have to draw. I'm going to write the steps down here at the bottom of the page. The very first thing you have to do is draw the new axis. So, how do you determine where that new axis is going to be? Well, sometimes you can eyeball it, sometimes you can't. You always want to check to make sure, and this is the thing people skip, the distance above and below the axis is the same. So a lot of times what you can do is in a sense, you're finding the midpoint between the minimum value and the maximum value. Between 0 and 2, the middle would be 1. So I know that for this first one, I'm going to draw an axis at y equals 1. My second step is going to be to draw the key points. The key points are the points on the axis as well as the highs and lows. Those are my key points. On the axis, on the axis, on the axis, high, low, high. Okay? All right. Now my third step is to draw or label my starting points. Now remember that sine always starts on the axis and goes up. Sine starts on axis and goes up. Right? And then cosine starts at the high and goes down. Now, I label them differently. I label my sine with stars, and I label my cosine just with this line. It looks like that. So I'm going to come up here to my picture. This is a starting point for sine, goes up, comes back down. This would be another starting point for sine. Cosine would be here and here. And I need to label all of my starting points that I can see on my graph. Okay. Now that I have set my picture up, I'm ready to go. And I'm going to make this my y equals sine of x. And I'm going to make this my y equals cosine of x. Now I'm just going to focus on sine. The phase shift, look at my stars, left pi or right pi. Which one is closer? Always go with the closest one. Well, they're the same, which means I have to write left or right pi. My vertical shift is up 1. Therefore, my equation is y equals sine of x plus or minus pi, because it's left or right. So even when it lies, it's right or it's minus, it becomes plus or minus, and then plus 1. If you want, you can add in the translation rule, which would be x plus or minus pi, y plus 1. That might be helpful to you. So there's my equation for sine. Now when I go to do cosine, this one is left pi over 2, this one is right. I'm pretty sure that's just, oh, that's 3 pi over 2. Or right 3 pi over 2. This one is closer, so this is going to be left pi over 2. I moved up 1. My translation rule then is x minus pi over 2, because the rule doesn't lie. Y plus 1. So my equation is y equals the cosine of x plus pi over 2 plus 1.